All right, we are cooking with gas, ladies and gentlemen. So welcome to class today. Right now, as you know, we are working through our first program in MATLAB. And when we take a look at our Moodle page, which may or may not have been available to you yesterday, you will see that our first assignment, or not our first assignment, but our first submitted assignment that actually had content in it is due at midnight at 11:59 p.m. tonight. So please submit that through Moodle. That is that handout for the temperature conversion problems as we're getting set up to program that using the MATLAB programming environment. So if you have if you had trouble doing it last night, everything is supposed to be back up and running today. If it is not up and running today, please let me know, but I will keep getting messages from our instructional technology folks if the system goes down. But do let me know. If you have any trouble submitting the homework, just talk to me because we can work out any problems that are happening. But in my perfect world, everybody would have that first homework assignment submitted through Moodle by 11:59 p.m. tonight. If something goes wrong with that, just let me know and we'll figure out the rest. Okay. So before we get started with that, let's take a look at the homework problem, which is right here. And I'm going to go ahead and share my screen with my zoomies out here. All right. So there are a total of 10 problems. And the first thing I want to know is, does anybody have any questions about this? Does anybody have any problems or anything that I can help you with? Yes, sir. Yes, Joey.
Because the different equations you wrote down for us, they weren't they didn't have a 0.15. Is that necessary? Because I looked it up and sometimes it happened.
Right. Using the decimal places is more exact. And this seems like a really simple question, but it's a very important question, especially for engineers. The answer is you can use either as long as you use the same all the way through. And the other thing is, the more important piece of this is the conversion factor that you use, regardless of what it is always considered exact. Okay, and this goes for everything that you'll do. So when you're writing significant digits, then you don't ever use the conversion factor to determine the number of significant digits. You always use your data that you're inputting. Okay, Garrett says, would you be able to write the formulas for the conversions again? And the answer to that is yes. I will do that after we do a little bit of bookkeeping. Make sure I've got the conversion formulas. Then keep in mind that you may need to convert between two formulas. So in other words, I did not write down a formula between like Fahrenheit and Kelvin. So you may have to go Fahrenheit to Celsius to Kelvin, or you can take the formulas if you're mathematically comfortable with it and rewrite them yourselves. So, but it's completely up to you how you do that. But yes, I will write the formulas down again. So the next piece of bookkeeping I want to talk about is this week and next. Okay. So there are just a couple of things that are going on. So today, excuse me, I have a frog in my throat. September 6th, we're having a regular class. That's just a regular day. Now, I had put it on our Moodle page, but I want to say again, on Friday, September 8th, which is a day that only computer science, COSC 1010 people meet with me. ES 1060, you're always welcome, but you are not obligated to go to that class. And the reason for that is because, of course, COSC 1010 is a 4-credit class. ES 1060 is a 3-credit class. So there's a little bit more content with computer science 1010. But this Friday, September 8th, we will have no class. All right. So we'll just continue with all of the homework. We have 4 different homeworks that are right now. We have the conversion factor worksheet. We have the MATLAB onboarding. We have the pseudocode, and then for computer science 1010, we also have a flow chart. So there's a bunch of stuff out there. So please use Friday to work on that on your own. September 11th is when the MATLAB onboarding is due. So we'll work together two times. We'll have both the lecture in the morning and the lab in the afternoon. But your assignment will be to have that done by September 11th. And then we'll have regular class on the 13th, and we'll have regular class on the 15th only for, well, this is what I wanted to talk to you about. This is a very special day. And even if you are in ES 1060, I would like you to attend or by Zoom or face-to-face. But if you are able to at all, please attend this day. The reason for that is there is a new Associate of Science leading to a Bachelor of Science degree that is being offered across the state of Wyoming. And the AS degree is going to be offered by at least 4 community colleges, including Northwest. And the BS degree is offered by UW. And the name of this degree is software development. So, and I can give you more information about it, but the reason that I would really like you to come on Friday is Friday at 9 a.m. Zoom or in this classroom. The person at Sheridan College who created this degree and has been the absolute leader on getting this established, Professor Mark Toney, is going to be joining us via Zoom to describe the opportunities that would be available to you through this program. So I would love for everybody to be here. You guys are, you may find that this is something that is really interesting to you, that may help you maybe not change your trajectory, but specify your trajectory as a computer scientist or as an engineer. So please plan to attend September 15th. I will also, with Mr. Toney's, Professor Toney's permission, I will record the lecture and put it on our Moodle page, but I haven't gotten his permission for that. And of course, I would never record without letting everybody know ahead of time. So please show up if you are able to. All right, does anybody have any questions about that, about September 15th next week, or anything about the homework or anything about the software development program? Yes, yes, Joey.
I didn't really understand what we had to do.
Okay, yeah, I'll go through, that's a great thing. Okay, so we'll talk about pseudocode in just a minute. And then I'll put the formulas down. Right, no, it's great. Who knows who, it's on one of the lectures and it should be videotaped, but I don't think I ever put a document up on our Moodle page, but I'll do that in just a second. All right, so we've talked about all of those things. The next thing is we will be meeting September 15th, but the following Monday, and then I won't go any further than this, but Monday, September 18th, once again, we will have no class because I will be off campus. So there's a K-12 initiative in Wyoming to start doing competency-based education, and they're having a kickoff focus group for that I got asked to participate in. So that's why I'm not going to be here, but so we won't have any class on the 18th. All of this will be on our Moodle page, so you'll be able to follow what's going on, but I just want to make sure that you know ahead of time. All right, any other questions before I write the formulas out and talk a little bit more about pseudocode? All right, so the conversion formulas. First of all, if you recall, we have 4 different temperature scales: F, Fahrenheit, which is degrees; Celsius, which is degrees; Rankine, which I did define. They also do use the degree symbol; and then Kelvin, which does not use the degree symbol. All right, so Fahrenheit is from the US customary system, and Rankine is based on the Fahrenheit scale, but 0 degrees Rankine is absolute zero. And absolute zero is that place, a temperature that seems that theoretically we cannot get below. And when I say theoretically, I don't really see any practical way that we could get below it either. It seems like it's an absolute limit in the universe, but I'm just doing that to sort of soften the blow, I guess, or to soften what I'm saying. Now, in the same way, we have degrees Celsius, which is part of the SI or metric system. And then corresponding to that, we have Kelvin, which is based on degrees C, except that 0 kelvins is also equal to absolute zero. So this gives us one point of connection, doesn't it? 0 degrees Rankine is going to be the same thing as 0 kelvins. All right. So if we draw a chart, and this is how I always construct this, this is part of problem solving, and that's why I do this chart, because just presenting a formula without understanding where it comes from is not necessarily a good problem solving technique. But here at absolute zero, we have 0 degrees Rankine and 0 kelvins. All right, then somewhere up here in our scales, let's do this. Let's do this as being Rankine, this as being Kelvin, and then in between we'll do Fahrenheit and Celsius. Okay, so on the Fahrenheit scale, water boils at a temperature of 212 degrees Fahrenheit at 1 atmosphere of pressure. On the Celsius scale, water boils at a temperature of 100 degrees Celsius, which also means just like 0 degrees Rankine is equal to 0 degrees Kelvin, 212 degrees Fahrenheit is equal to 100 degrees Celsius. Okay. Now, another point is where water freezes at 0 degrees centigrade. Or excuse me, it does freeze at 0 degrees centigrade. That's not what I meant to say. At 1 atmosphere of pressure. Okay, so those of you that study engineering will learn a lot more about how fluids boil and freeze and how it's affected by pressure. Maybe the last time the computer scientists will see it. But on the Fahrenheit scale, water at 1 atmosphere freezes at 32 degrees Fahrenheit, and on Celsius scale, freezes at 0 degrees Celsius. Okay, so that also means we have another point of connection. 32 degrees Fahrenheit is equal to 0 degrees Celsius. Okay, so what that means is that the span of a degree centigrade is bigger. Centigrade and Celsius, I use those two terms interchangeably, but the span is larger. And the fraction, if you take 212 minus 32, that's 180. 100 minus 0 is 100. 180 divided by 100 reduces to 9/5. So that means that there's a factor of 9/5, and there's also an adding or subtracting of 32. So if you think about this, temperature, all 4 of these are linear scales, which means that they follow the pattern y is equal to mx plus b. All right, so m would be a conversion, b would be the difference from zeros, and then y and x would be the temperature scales that you're using. So that's sort of the way that the formulas are developed. So thinking about Fahrenheit, we know that a Fahrenheit degree is going to be bigger than a Celsius degree. So if we start with Celsius degrees and we multiply it by 9/5, and then we add 32, we're going to get degrees Celsius. Going backward, if we solve this equation for degrees C, we would get degrees C equals Fahrenheit minus 32, but that's in parentheses, times the reciprocal, which is 5/9. Okay, so I'm gonna write my first 2 conversion formulas here. Degrees Fahrenheit is equal to 9/5 degrees centigrade plus 32, or 9/5 is 1/8. So we could write that as degrees Fahrenheit is equal to 1.8 times degrees Celsius plus 32. There's our first conversion factor. Degrees Celsius or centigrade is equal to, in parentheses, we do order of operations Fahrenheit first, 32 times the reciprocal 5/9. Okay. And I can't actually remember what, I think it's point, oh, I turned my phone off, never mind, and I don't have a calculator. Will somebody find the decimal equivalent for 5/9 for me? 0.55 forever? Okay, so we'll go like that. Times degree Fahrenheit minus 32. Okay, so then since these are centigrade and Fahrenheit are based on the same, our kelvins and Rankins are based on that same scale. The only thing we need to know is where our zeros are. So if we go to, let me share my screen. And you are always welcome, unless I tell you differently, to look up conversion factors. But degrees Celsius to kelvins. Let's do that. All right. So the other thing I would like to tell you is that as an engineer or a computer scientist, you really should double check your ideas about what conversion factors are every single time, because there are cases where huge problems have occurred because somebody assumed that they knew a conversion factor. One, if you ever look this up, if you're ever just bored and you want to look at something interesting, there is an airplane that the pilot actually landed it safely, but it ran out of fuel in Canada. And it's sort of colloquially referred to as the Gimli glider, Gimley, Gimli glider, because the pilot basically glided it down to an abandoned airstrip where a bunch of people were having a picnic. I know, cool-headed guy, man. I mean, he did it, but that he ran out of fuel because somebody had misconverted between pounds and kilograms of jet fuel. Another one more recently, there was a Mars rover that was put into orbit around Mars and crashed into the surface of Mars because somebody had done a conversion factor incorrectly. So conversion factors are a big deal. So I'm telling you, always look them up. So, so we see that 0 degrees Celsius is equal to 273 degrees Kelvin. That means that kelvins are degrees Celsius plus 273. And I'll go ahead and put the decimal in. Joey had asked about that, which I think is really important. But if you use 273, it's fine, especially if you're doing handwritten problems and you don't want to keep multiplying by that many digits over and over again. Just use 273. When we write our code, probably you'll be more interested in using 273.15 because the code will do the work for you and you don't have to worry about that. All right. So now let's go degrees Fahrenheit to Rankine. And the conversion factor for that is 491.67. So we can also then say that the Fahrenheit degree, that's 491. I want 0 here because I want to get the number for my equation. There we go. 459.67. That makes me much happier. Okay, so if we take Fahrenheit degrees and add 459.67, we will get degrees Rankine. All right, so I'm going to flip over to my desktop again so you can see the conversion formulas. And there they are. So you can degrees Fahrenheit, Celsius to Fahrenheit, Fahrenheit to Celsius, centigrade to Kelvin, Fahrenheit to Rankine. Any questions? We're good. All right, how about yeah, you're welcome, Garrett. All right. So having said that, then let's talk a little bit more about pseudocode. What is pseudocode? All right. So pseudocode is articulating a problem to be solved. So it is done before we write any code or we even turn on a computer. All right, so what do I mean by that? Well, the answer is that when you write computer code, the reason for pseudocode, I guess, is you have to spell out, you have to know exactly where you're going before you start writing code. And that's what pseudocode does for you. It helps you figure out what you're going to code. Because if you just start coding before you have a very clear idea of what your problem that you're coding is, you're going to mess it up every single time. So what this really does is it separates out the problem solving step from the coding step. Okay, so let's talk about, I'm just going to do this. This is what I want, my objective. And I'm just going to do, this is like a tiny wee little piece of our code from what we're doing. Okay, we want, the objective that I want is to have a user input degrees Fahrenheit and solve for degrees Rankine. Okay, so you can see this is like a little slice of what we're going to be doing with the code. All right. The theory or the formula that we're going to use then is what is the conversion factor between these two? The theory is that degrees Fahrenheit is equal to input Fahrenheit equal to, oh, I did this backward. Degrees Rankine is equal to degrees Fahrenheit plus 459.67. And I have a condition or a restriction, which is I know that degrees Rankine can never be below 0, right? So the condition is degrees Rankine has to be greater than or equal to 0, which means that degrees Fahrenheit has to be greater than or equal to 459.67. Okay. And then my output is going to be degrees Fahrenheit equals this many degrees Fahrenheit, whatever I input, is equal to this many degrees Rankine. Okay, so what I've done is I've defined my input, my output, and how I'm going to get between the two. And that's how, and you see how this piece of the puzzle is exactly the same regardless of what language we use, right? So 90, I'm going to say 90, that's going to be an exaggeration. 60% of what we do as computer scientists and engineers is language agnostic or independent of language. So you solve the problem and then you later write the code. Okay, so this is kind of what pseudocode would look like. Now, you have to think about some things. Let's say, for example, here, a degree symbol is difficult to enter, right? So it's not impossible, but we want the user to input a number, a letter, let's say, if we had more than one, because you will, and then a number. So, for example, we're going to specify that. We're going to ask the user how many, you would phrase this better, degrees Fahrenheit, because you can type this in using code, and then they're going to answer 16.4 or whatever their input is. Okay, you don't want them to put 16.4 degrees Fahrenheit. You just want them to put in this. Now, if we had two different scales, we would have to ask it for what degrees or what scale are we using, and then they would input, for example, F or C, or let's just say F or R if we're going back and forth. Okay, now you have to tell the computer then, are you going to accept small f, minuscule, and or just majuscule? So are you going to accept little f and little r, or are you just going to accept capital letters? And so what that means is if your user has a choice of inputs, if it is invalid, you have to print out something that says that would be an output, invalid if the input is not, like say capital F, for example, or capital R, or whatever you choose up here when you code it, or if the numeric value is less than 0 degrees Rankine, or less than, that should be a negative, negative 459.67 degrees Fahrenheit. All right, so is that helpful, Joey? This is really what pseudocode is. It's just breaking down step by step what your problem solving is going to look like. All right. So I brought an example. Oh, let's see. Garrett asks, question on the last problem on the temperature conversion homework, which rule doesn't allow a certain temperature to go below a certain value? The answer is, Garrett, that no temperature, it is not possible in the physical world to go below 0 degrees Kelvin or 0 degrees Rankine. Okay, it's because that appears to be a theoretical and probably a practical limit. So any input that would cause degrees Fahrenheit to be below negative 459.67, or allow centigrade to go below negative 273.15, or to have kelvins or rankines go below 0 is not valid. Okay, it's sort of like, let's do an example, maybe makes a little bit more sense. Let's say you're computing the area of a room, and the room is mercifully rectangular, which sometimes doesn't actually happen, but we're going to say it is. So we have a width and we have a length, and the area is the width times length, right? Well, what if you ask the input width and then input length? All right, what if this width is entered as a negative? In other words, this number has to be greater than 0 and this has to be greater than 0. If you entered width as negative 4 feet and you entered length as negative 8 feet, and you multiplied them together, you get an area of negative 4 times negative 8, which is positive 32 feet squared. Okay, is that real? Or is that just something that happened because of the way math works? It just happened. There is no such thing as a negative width. There's no such thing as a negative length. So you're violating something in the real world. So even though it's not as common to us, it's the same thing with temperature. If you go, there's no way you can go below that. So, Garrett, does that make sense? Yes, that is correct. There are a couple of problems that are purposely invalid because I want you to catch them and then say, don't write the answer as the numeric answer, write this is invalid because K is below 0 or whatever that happens to be. Good question. All right. So, and this is very important when you're solving things in the real world. There are so many instances where things work out on paper, and yet in the real world, there is some barrier to them happening. And so the negative width and length is one that I think is kind of obvious. I mean, it's something more familiar to us, but temperature is the same sort of thing. And there's lots of things where there are certain laws of the universe where things can't be below 0 or can't be below each other, or there's some sort of a comparison that you have to do. And so this is an important thing that we need to take into account when we're coding. All right. Any other questions about that? All right. So what I want to do today is, the last thing I want to do is to show you a very old computer program and how it's laid out. This will be a little bit, not a little bit, but quite a bit more complicated than anything that we're going to do today. But I just want to show you basically what a flow chart looks like. A flow chart is what builds directly out of pseudocode. This is before any coding language has to do, but basically, this is a problem statement. And as I said, we're not going to go through the whole thing, but each one of these symbols has a different meaning, which if you're in ES 1060, you do not have to do that. If you're in computer science 1010, we talked about it on Friday, but basically, the start of the problem, you name the problem or put start here, and then you take some input, and then you make a calculation, and then you decide what's going to happen. If some condition is not met, here if k is greater than k max, you do a loop thing and you do some other stuff and you do some more loops until you come out with something at the end. And then you do a calculation, which is a rectangular thing. All right. So there's some decisions to be made here, and then you have to go back and you have to recalculate until you get down to the end, which is an output statement. Okay, so you do calculations and then you do some output, which here is right. And then you do some more stuff. And then when you're at the very end, you produce something and you end the program. All right. So this is a pretty complicated problem. And it's going to be, I swear, I'm not going to make you guys do anything that looks like this, but you will have things where you'll have a loop. For example, let's talk about that. When you're inputting stuff in degrees, you're going to ask your user for input. And the first thing you're going to do, I can't draw these, that's why I have the templates. The templates are outside my office, so if anybody doesn't want to hand draw these, please help yourself. But you're going to say input, either F, C, K, or R, right? And the first thing is then you're going to look at the input, and if it is not F, C, K, or R, for example, if they put in a little f, unless you've accounted for that, or if they put in a q or some other, 400, you have to go, you have to say if it's equal to f, then do this. If it's equal to c, then do this. If it's equal to k, then do this. And if it's equal to r, then do this. And if it's not equal to any of those things, you have to write to your person invalid input. And then say K, F, C, or R only. And then you go back to the top and you hope, and you ask them again for a piece of input. And you can do that. The computer can do that all day. You can keep doing that forever and ever if the user does not put in the right amount of the right data. But if, for example, they put in an F, then you would have some calculations that would say C is equal to this, R is equal to this, and K is equal to this. Now, specific to MATLAB, over here in your workspace on the right, it will hold those variables for you. So you'll define F, C, K, and R, and it will tell you this will be what they input, the number, and these will be the calculations. But if instead of putting in an F, they put in a C, you wouldn't calculate C, K, and R, you would calculate F, K, and R, and so forth. And then at the very end, if it calculates if K is less than 0, or if R is less than 0, you once again need to tell your user invalid number, K cannot be less than, K, how do I do that? K cannot be less than 0. I don't know what that symbol looks like. Just occurred to me as I was writing this. I have no idea. So if it's not equal to, of course, you draw a slash through it, but if it's not less than, is this a valid symbol? I do not know. So there you go. Are they choosing the conversion? Says, yes. Example, put F to C, input K to F. No, you're gonna ask them to input F or input, and if they input F, you're gonna calculate C, R, and K. If they input C, you're gonna calculate F, R, and K, and so forth. Good question. Thanks, Stephen. Sorry, it's not Stephen. I lied. Sorry about that. So go ahead.
basically putting on.
Yes, you'll have them put in a unit and then you'll have them put in a value. Absolutely. And then you make the other three calculations, but at some point you have to determine if it's invalid. Okay. So does that give you a path forward?
Mhm.
Okay. All right. Now I'm going to live dangerously for a minute here because I'm not sure I can pull this up, but if I can't, I'll do it and I'll do it on Monday. But when I did this program a few years ago, so I'm going to see if I'm able to access it here. So for me, let me share my screen. And like I said, if I can't, I'll have it worked out on Monday. I came in here a little bit early and nothing was working properly, so there you go. But I have an online account, so I'm going to go to MathWorks. MathWorks. And the neat thing about MathWorks is it will keep everything for you. If you write a program, it will keep it for you basically forever. So I'm still on a free account, and I don't know why that is, because it keeps telling me every time I log in, it tells me you have 15 days or something like that. This is where the trick becomes. Let me see. Maybe. Yeah, okay, there we go. Let me get rid of this. It doesn't like it. Let me come up here. Yeah, it doesn't like my email. I'll have to figure it out. Like I said, I was living dangerously by trying this, so yeah. Oh, it liked the first one, it just didn't find it. Okay, there we go. I got lucky today. All right. Let me see. I'm going to share my screen. So these are just some programs that I have written in MATLAB. And basically, let's see, here's my final attempt. Let's see if it'll pull up my code for me. There it is. Okay, so basically, this is not the same program that we have written. Oh, here it is. Here we go. This was, okay, so in MATLAB, just so you know, if you put a % in front of something, that's just a text message to yourself. The onboarding program also shows you that you can just click a button called text, but anytime you just want to do this, you can do it like this. So basically, you'll see what I've done. I've done some comments to myself, just describing what it is that I want to do. And then I talk about some input. But here we go for values of R and C. So basically, I ask for this value and it gives me a value, and then it creates those three other formulas based on that value. So I'm using that data structure, which is an else if. So in other words, if I type in an F, then it goes like this. If it types in an R, it goes like this. If it types in K, it looks like this. Else, and then it tells me that there is an invalid request. And then at the end, I print stuff out. And I have two programs mixed together here. I don't really know what I'm talking about. So I'll have to, this program, I don't even know what it's going to do. But anyway, basically the display means that that's what's going to show up when they type it in. So they'll type their stuff in and then it will display these things. So apparently for some reason, I have two programs merged. I did one I started to do one for temperature conversion, and then I switched over to doing this one for the diameter of wire. Basically, if you're carrying electrical current on a wire, different types of metals are better conductors than others. So I'm asking to see if anyone knows this answer. What is most electrical wire made out of? Yes. And Why do you suppose that is from an engineering point of view? Yep, conduct a lot of electricity is right. And there's one other reason for it. Gold is a really good conductor. It's very malleable, yes. So you can pull it into a wire very quickly. Another reason is it has good corrosion features. It doesn't corrode easily. It does corrode, but it doesn't, well, it oxidizes, but it stays intact. And the other reason is the amounts that are available. So in other words, when you mine copper, you get it out in pounds and tons. Gold is another good conductor. It's not as it doesn't have the same corrosion properties. Really, gold is a great conductor, but it's quite expensive, right? You mine it in wee little quantities and costs hundreds of dollars an ounce, whereas copper costs dollars per pound. So there you go. It's still, and that's why I find big rolls of copper wire. You don't find big rolls of gold wire. But anyway, so that's what that program was doing, is like, if I'm conducting so many amps, what is my diameter going to be if I have gold or copper? Another one that they use, because it's a widely available industrial metal, is, well, okay, in the United States, we pronounce it aluminum. In England, they pronounce it aluminium, but it's the same thing. So aluminum is another one. It has, but it's not nearly as conductive, but it's way cheap. So in a time in times where the price of copper goes up very high, people will try to use aluminum for more and more applications. So there you go. All right. So that's kind of it for today. Do you guys have any questions for me at this point? All right. So I will be looking for your homeworks tonight. I will grade them probably tomorrow. But if you have any questions or problems, if you have trouble with, hang on. So, yes, that is correct. The output will be all three of the other values. That's right. So if you input F, you'll output C, K, and R, and so forth. Good questions. Good questions. So anyway, I'll be looking for your stuff. If you have any trouble either with the problems or with submitting it, please let me know. Also, just as a closing note, please remember, if you don't submit it as an HEIC file from an Apple phone, because I can't read it. So if you're taking a picture and submitting it from an Apple phone, make your Apple phone submit it in a different format. And PDF is my favorite. You'll make me happy if you submit it as a PDF, but JPEGs are great as well. All right. No other questions? All right, then. So I will see you guys Monday. And even though I will not be on campus on Friday, I will be available to answer questions. So please get a hold of me if you need help. Thanks, everybody.